Exercise 1103, the Capture Recapture technique, is a calculation. It's a technique, but really what you're doing is you're estimating the population. So it's a calculation we do to estimate the population, and it is totally dependent on the assumption that a sample will reflect the entire population. So what you can see here is this fraction that is formed. We're going to assume that the fraction that we form based on the sample, a sample that we take, so a fraction that we'll form based on a sample will be exactly equal to a fraction representing the entire population. So it's really important that this sample is a very good sample. Now, like I said, this is a technique in order for us to be able to estimate the size of a population. Now you might wonder why you couldn't just count them, but for example, if you thought about fish in a lake, you wouldn't be able to count them all because you wouldn't be able to see them. So there are some populations that we have to be able to estimate the size. So what happens is, and you might have performed this actually in a science class when you're trying to estimate the size of bugs in the garden. If it's possible, you collect a small group, and that's where the capture comes from. So you take a small group and you capture them and you tag them, but then you release them back into the entire population. So you've tagged some. Now that fraction that you have tagged, now the way I've actually seen this operate in biology here at St. Mary's is that students go out and they collect the little slaters, the little bugs in the garden that roll into a little ball, and they mark them. So they might collect 50. And the way they mark them is usually just with liquid paper. Just put a little daub of liquid paper on them. It doesn't hurt them. And they release them back into the garden and let them mix with the entire population. And they might come back 2 or 3 days later. Now, what they're going to assume is that the way they were spread throughout the whole population will be the same as if they go back and take a sample 2 days later, that the number that are tagged in that total sample is the same proportion as the total that were there in the entire population. So after the groups have mixed, a sample is recaptured. So it's a sample, and that's why it's called capture. Yes, initially a group are captured and marked. They're allowed to mix in with the entire population. A small sample is recaptured, and the fraction that are marked or tagged out of the total in the sample, that fraction represents this fraction out of the total population. Okay, and you can see there that this is a number. So let's say that was 50. This is the population X. We don't know it. When we get our sample, we might only collect up 30, and we might find 8 of them are marked in our sample of 30. We would continue collecting them until we found at least one marked one. So we wouldn't stop, otherwise we wouldn't be able to form this fraction. So you can see a number, an unknown, a number, and an equal sign. That gives us an equation. And what can we do to that equation? We can solve it in this case for x, which actually represents the population. So if we find the value of x, we've found our estimate for the population. So here in this example, we've got Emily as a biologist estimating the populations of crabs in a lake. She randomly captures and tags 64. 3 months later, she must have tagged them and then re-released them. She later samples 50 and she finds that 8 of them have been tagged. What would Emily's estimate for the total number of crabs in the lake be? So we start off tagged over the population, and you can call that x, will be the tagged in the sample, the recaptured sample, over the total in the sample. Now substituting that, so 64 were originally collected over x. That's what we're going to try and find. The tagged number was 8 out of the 50 that she recaptured. You can see an equation. We're going to solve it for x. Cross multiply. 8 times x is 8x. 64 times 50. Divide both sides by 8. You get that x is equal to 8 8s is 64. 5, that's 40. 400 crabs. You should be right to go on there with it. 1103.